So in this worksheet, I've already completed problems 1 through 4. They'll be part of the key. If you have any questions or concerns on them, please let me know. What I want to focus on here is actually the very last 2 questions on the worksheet, which are writing an equation when you're given either secant or cosecant and how to figure out what you've got. So I'm going to zoom in on problem number 5. Now, what I do is I'm actually going to draw in the sine or the cosine curve. And if I can figure out the sine or the cosine curve, I can then figure out the reciprocal function to know if we're talking about secant, cosecant, and what its attributes are. So I know that I would have a curve that it's going to hit these points right here, and it's going to cycle between them. So something like that. Now, it may not be perfect. I'm not really looking for perfection, but I am looking for kind of the shape of the graph. Now, a couple things jump out to me. First thing that jumps out is I know my period is 2 pi, okay? Because I can see that this is one full cycle here. So these two curves together would be one full cycle, and that's 2 pi. Vertical shift, none, right? Our midline is right on the x-axis there. Amplitude for the sine curve or cosine curve is just going to be 1, so I don't have to worry about a coefficient here. And if I look at this part of the curve, and I'll go ahead and highlight it in, let's say, green here, this curve right here is the standard sine curve. Since that's the sine curve, no reflection, nothing weird about it, sine is reciprocal to cosecant. So the blue curves could be f of x equals, except I need to spell it right, cosecant of x. There's no reflection. We did not have an amplitude change in this sine curve, so no change here for this coefficient. Period, no change. Vertical shift, no change. So that is the cosecant curve. I'm going to go ahead and slide over to number 6, and I want to do kind of the same thing. I want to match up whatever curve I have. So if I pick the minimums and maximums here, it gives me an idea of what my curve kind of looks like. Again, not perfect per se. Wow, that was really bad at the end there. This one's just awful. But I kind of get the feel for what's going on here. And what's going on here is this is a cosine curve, right? It's off center. It's at a minimum or maximum point here. Minimum for cosine, maximum for the secant curve. So things I need to pay attention to. This cosine, if you want to make a little note to yourself, has a amplitude of 2. It has a period of 2 pi, phase shift none, and vertical shift none. So what does that tell me? Well, I do one other quick thing. Hold on. One thing. There's a reflection here. All right. The reason I know it's a reflection is because we're starting off center low on the y-axis, not off center high. So I know there's a reflection. So cosine is the reciprocal to secant. So let's go ahead and do secant. So g of x is equal to. Now I need to accommodate this amplitude of 2 for cosine, which becomes the coefficient of secant. Secant of x. And one other thing, which of course I did not leave myself space for, this whole thing needs to shift because I need to put a little negative sign right there because that will get me the reflection that I was looking for. So cosine's are reciprocal to secant. This amplitude for cosine becomes the coefficient of secant. It's not really the amplitude of secant, but it is the coefficient. Period of 2 pi means x does not have a coefficient that we have to worry about. Phase shift and vertical shift, none and none. Reflecting over the x-axis means we're going to throw a negative in front of that coefficient to force the reflection. All right, if you have any questions or concerns on writing the equation for secant or cosecant given a graph, let me know. If any of the questions 1 through 4 are causing you issues or concerns and you want to see a video, or you just, let me know what's going on, what you need help with, and I will help you out.